You can mail us at support@economicsexam.com or reach us at https://www.economicsexamhelp.com. 1. Consider the following regulation problem. Let X be output, C be marginal cost of output, and R be net return of production. The firm's net profit before regulatory payments is given by Microeconomic theory. Problem 1. Note that X has to lie in the unit interval and that output has been normalized to equal revenue. Assume that the regulator does not know the firm's cost coefficient C, which can take on n values, 0 less than or equal to C, 1 less than or equal to, less than or equal to Cn less than or equal to 1. The regulator assesses probability pi greater than or equal to 0 to each of the I possible marginal cost levels. The firm knows its marginal cost and chooses X. The regulator can tax the firm based on its realized revenue. A. Set up the program that solves for the regulator's optimal policy, expressed as a direct revelation mechanism. Assume that the regulator's objective is to extract as much surplus from the firm as possible, subject to the constraint that the firm can quit if profits are negative, and pay nothing. B. Draw a diagram that shows how the firm chooses its best response as a function of its cost. Prove that the firm's output choice X is a non-decreasing function of marginal cost. 2. Consider a screening model of the following sort. The agent produces economicsexamhelper.com. Output Q at a cost C, Q beta equals Q beta, where Q is output and beta is a cost parameter. The principal, who cannot observe either C or beta, offers to pay the agent the amount P, Q, if the agent produces output Q. Given this incentive scheme, an agent with cost parameter beta responds by producing the amount Q, beta. What kind of payment scheme P, Q, should the principal choose in order to implement the response function Q, beta, equals 1/beta 2? Asterisk 3. A seller may supply a single object to a buyer. Let X be 1, if trade takes place, and 0 if not. Let TS be the amount of money that the seller receives and T be the amount that the buyer pays. Let V be the buyer's valuation and S be the seller's valuation of the object, and assume preferences are quasi-linear. We can then normalize utilities so that the seller's utility is TS minus CX and the buyer's utility is VX minus TB. Assume the preference parameters V and C are independently drawn from a uniform distribution on 0, 1. The buyer knows V and the seller knows C. What is the efficient rule for trade? B. Let MS and MB be the seller's respectively the buyer's reported preference for the object. Determine the set of direct mechanisms, expressed as a function of the reports, that admit truth-telling as a dominant strategy and implement efficient trade, i.e. the set of Grove's mechanisms. Economicsexamhelper.com. A. Show that IC and IR are satisfied for any P. B. Show that there is a value of P such that the mechanism is balanced and trade is efficient. Economicsexamhelper.com. C. Show that there is a unique Grove's mechanism that has the property that whenever trade does not occur, the transfer payments are set equal to 0, TB equals TS equals 0. Is this mechanism feasible? D. Show that there is no Grove's mechanism for which the budget breaks even for all reported preferences. 4. Suppose there are a continuum of sellers and a continuum of buyers, where each continuum is normalized to 1. Each seller has one unit of the good and has valuation versus drawn, independent from those of the other sellers and buyers, from the distribution Fs on A, B. Similarly, each buyer has unit demand and has valuation VB drawn, independently, from the distribution FB on C, D. Assume that B greater than C, not everyone ought to trade. Let MS versus and MB VB denote a seller's probability of selling and a buyer's probability of buying, respectively. Let TS versus and TB VB denote a seller's transfer and a buyer's transfer from the planner, respectively. Among the many possible mechanisms that might be used, consider the Walrasian mechanism. Solution 1. A. Let TI be the total tax payment by the monopoly of type I. The program is as follows. B. The firm's profit has strictly decreasing differences in C and X, so any implementable 11 must be weakly decreasing in I. To see this, simply add up the IC constraints that types I and J do not imitate each other, and the TI and TJ cancel out, and we obtain that. It can be rewritten as CI minus CJ, 11 minus XJ, less than or equal to 0. Therefore, if I greater than J, so that CI CJ, then 11 less than or equal to XJ. C. Since the firm's profit is decreasing in I, the IR constraint is only binding for type N, which means that Tn equals 1 minus Cn xn. At optimality, type I is indifferent between reporting I and reporting I plus 1, so Ti minus Ti plus 1 equals 1 minus Ci, 11 minus 1 minus Ci, 11 plus 1. Convince yourself this fact if you did not come to recitation. Therefore, economicsexamhelper.com. economicsexamhelper.com. C. The Meyerson-Satterthwaite theorem states that it is impossible to achieve efficient and individually rational trading in a Bayesian NE between a buyer and a seller with private information about their valuations. How can this be reconciled with parts A and B above? The summation is type I's profit. Therefore, the regulator's maximum payoff under a production plan, 11, is. The constraint is that 0 less than or equal to xn less than or equal to xn minus 1 less than or equal to x1 less than or equal to 1. Since the objective function is linear in 11, each 11 reaches its upper bound, 11 minus 1 if I greater than 1 or 1 if I equals 1, or lower bound, 11 plus 1 if I less than n and 0 if I equals n. Therefore, there exists a k such that 11 equals 1 when I greater than or equal to k and 11 equals 1 if I greater than k. By EQ, 1, Ti equals 0 for I greater than k and for I less than or equal to k. Solution 2. Notice that C, Q, beta has strictly increasing differences in Q and beta, so every non-increasing Q, beta can be implemented. Indeed, Q, beta, equals 1/beta 2 is decreasing in beta. The envelope theorem implies that the transfer schedule T, beta, that implements Q, beta, is unique and is given by where beta 0 is a type, pi, beta 0 is a constant, and C2 is the partial derivative of C with respect to its second argument. Substituting in Q, beta, equals 1/beta 2, we obtain that. economicsexamhelper.com. 2 let A equals pi, beta 0, minus beta 0. Notice that beta equals Q, so Solution 3a. Since utilities are transferable, the efficient trading rule maximizes the total surplus, V minus C, X, which means that X equals 1 if and only if V greater than or equal to C. B. Let X MSMB be the trading rule, and TS MSMB and TB MSMB be the transfer rule. Then in a direct mechanism that implements efficient trade, X MSMB equals 1 if MB greater than or equal to MS and 0 otherwise. The seller's payoff under this mechanism is it is required that MS equals C is optimal for all MB. Since the seller can choose the MS that maximizes TS MSMB under the same physical allocation X MSMB, there exist two functions TS1 MB and TS0 MB such that TS MSMB equals TS X